Hi, I'm Mr. McCollum, and this will be your lecture for Thursday, February 10th, 2011. And today in class, we talked a little bit about pressure. Yesterday, we had talked about it a little bit conceptually. Now I wanted to do a math-based approach, so that's what we did in class. So we began the period by talking about a review of SI units. And if you remember, the SI unit is any standard unit we measure in. And you can put science in parentheses. So the standard unit we measure in science. Alright, so if you weren't present that day, you might want to take out a sheet of notebook paper and kind of jot that down. Alright, so the SI unit is the standard unit we measure in science. Now, what kind of SI units are there? Well, think in terms of measurement. We talked about the SI unit for measurement. Right here in America, we use the inch, the foot. What about in Europe? Well, Europe, they use the kilometer for very long distances. They use the millimeter and the centimeter. But the actual SI, or base unit, contained in all of these names is the meter. Alright, just plain meter. Now, when we weigh ourselves in America, we get on the scale and we notice a representation of our weight in pounds. Overseas, we might see this as kilograms. If we were to get a carton of milk from the grocery store, we might see that represented as gallons. Overseas, the SI system sees that as liters. Okay, liters. Now, there is also an SI unit for pressure. Alright, so pressure. And the SI unit for that is known as the Pascal. P-A-S-C-A-L. And we abbreviate this P-A. Capital P, little a. The Pascal. So today we're going to be doing some calculations about pressure using the Pascal. So here's the basic equation we're going to use to calculate pressure. Alright, so pressure, capital P in parentheses, to abbreviate pressure we use the capital P, equals force. And remember, we measure force in newtons, represented by the capital letter N. Newtons. Divided by, then, the area. Now, for our particular problems, I'm going to be looking specifically at the area of a rectangle. Alright, so the area of a rectangle, then, if you remember back to math class, is length times width. Alright, so if you had, for example, this first side, right here, this up and down side, let's say that that was 3 meters. Then we said the width of this rectangle was, let's go, 6 meters. Just making these numbers up, okay? Now, with a rectangle, something special happens. We have congruent sides, or identical sides. If this is 3 meters, then this must also be 3 meters. And similarly, above here we have 6 meters. Down below, will also have 6 meters. So the area then becomes something known as square meters, or meters squared. Some people might read it meters to the second power. However you want to read it is fine with me. Now here's why. Think of this as a meter and this as a meter. Alright? That is 1 unit of area represented by meters. Then you have the width, which is also 1. So, in essence, since we have 2 of each, the area then becomes meters times meters, which equals meters squared. That's why we represent it that way. Okay? So, let's do an example. If I gave you force as 25 newtons, and then I told you that area equals 10 meters squared, what then is pressure? Alright, so for the first one, let's start off by actually giving you the equation, alright? We kind of wrote it out in longhand, but here is the shortened version. P, which we remember represents pressure, equals the force, represented by the letter F, divided by the area, which is A. Okay? So, if we're told that F is 25 newtons, where would we plug that in at? It turns out right here in the numerator. So, 25 newtons over, what's A? 10 meters squared. Now, the easier thing to do here is to separate your units from your actual math problem. We have one calculation here. Alright, so if it's easier, draw a little rectangle around the units. And just do the number part, the 25 over 10. We would be able to do this mentally, right? Because the rule of the 10 is we move the decimal point once to the left when dividing. So, 2.5 is our number answer. Then just carry over the n over the m squared. Alright? N is still on top, and m squared is still on top. Okay? Now, if I were to tell you that n over m squared equals the same thing as a Pascal, what could you tell me about this 2.5 n over m squared? Well, it turns out that 2.5 n over m squared actually becomes 2.5 pascals. 2.5 pascals. Alright, rewind this video and play it again if you are unsure of how I got that answer. Let's go to the second example I want to give you. It says if F equals 1,000 newtons, 1,000 newtons, and area equals 100 square meters, again, what is pressure? Remember your equation. Use the same equation as before. P equals F over A. F is here. 1,000 newtons divided by or over area 100 square meters. Now, doing 1,000 over 100 uses a very special rule, right? So this is also a power of 10 rule. Remember, we can cross out as many zeros that we have in the denominator and as many zeros as we have in the numerator equally. Doing what we have left here, we have 10 divided by 1, alright, which equals just 10. And then, keeping your SI units on the top, newtons and meters squared on the bottom respectively, and then using the identity for newtons over meters squared, again, this turns out to be yet another example of where you can get pascals. Let's try a story problem. Again, rewind if you need to watch that example again. It says a rectangular swimming pool measures 5 meters by 8 meters. Let's start by drawing the picture. Pretend that this is a perfectly drawn swimming pool. And it tells us that the dimensions of this pool are 5 meters by 8 meters. So this is the shorter side, 5 meters, and this is the longer side, which is 8 meters. Okay? So, knowing what we know about a rectangle, we have 2 identical sides for each length that we're given, right? So, 8 meters then is the same here, and 5 meters is the same there. Alright, so it says, suppose water level in the pool creates a force of 10,000 newtons against the swimmer. What is the pressure in the pool? Well, we're given force, which is 10,000 newtons, right away, but area is unknown this time. How would you find area then to solve for pressure? Well, it says our swimming pool is rectangular, right? And if you remember from math class, we said that area of a rectangle is length times width. So, plug those numbers in that you have. Area equals length, 8 meters, times your width, which is 5 meters, equals, now just do your numbers first, okay, we have 8 times 5, 40. What do we have left? M times M. That becomes meters squared. We now have the SI unit necessary to plug in for area. So we now know that area is 40 square meters. Okay.